Hi students, today we'll be going through turning effect of forces, GCE O-Level Physics OEQs. Let's get started with the first question. A child has a set of wooden 3D capital letters. Which letter is the most stable when standing upright on the table? So keyword right here is actually most stable. Most stable wise, right, we are looking at the lowest CG, center of gravity. So let's analyze one by one. What we can do is by elimination. B and D would be immediately eliminated because of the smaller base. Small base means more unstable. Hence, B and D are immediately out. Comparing A and C, right, the base is actually about the same, so we cannot compare the base anymore. What we can compare is actually the mass that is on top. So right here, R as compared to this H, actually there's a more mass here. More mass. So the larger the mass, the less stable it is because the center of gravity will be higher. Hence, the most stable alphabet would be A. So let's take a look at the answer. A. Stability depends on the position of the center of gravity. Correct. Okay, so here, right here is also by elimination. B and D are less stable because of the small base. And comparing A and C, C has more mass on top, so higher. Let's move on to the next question, question 2. Diagram shows a plank supported by a pivot. A block P is placed at one end of the plank and block Q of weight 400 Newton is placed on the other end. The weight of the plank can be ignored. What is the weight of block P in order to keep the plank horizontal? So keyword right here is actually to keep the plank horizontal. It means that we are looking at equilibrium. So for moments, right, in order for the plank to be in equilibrium, we need the sum of clockwise moment equals to the sum of anti-clockwise moment. Okay, so what do? We analyze the block. So the block is right here, the weight acts on it like that. The horizontal, the perpendicular distance is here, about the pivot. So from this direction, it turns anti-clockwise direction. Okay, the other part right here, this is the weight of the block Q. Perpendicular distance is right here. It turns this way. So this one is actually the clockwise moment. Okay, so moments wise, we'll use force times distance to equate them together. So these are the options that we have. Okay, answer is B, but we'll see the working. Total clockwise moment equals to total anti-clockwise moment. Okay, so from here, we take 400 times 0.9 meter. Okay, things to note about this topic, right, is that the unit, it must be Newton meters. That's why we are taking Newton times meter. In the event, if the question given is like in terms of cm, you have to convert to meters first. And from here, yes, this part is actually the weight of plank, the block P times the perpendicular distance. So by simplifying, we'll get 240 newtons. Hence, the answer is B. Let's move on to the next question. A brick has length of 0.21 meters, width 0.10 meter, and a depth of 0.06 meter. Okay. Density of the material is given. Density has a formula for it. Density equals to mass over volume. So we may or may not need it later. Let's see the question later. Okay, calculate the volume of one brick. Okay, since we are given the length, width, and depth, That means we need to use length times breadth times height to find the volume of the brick. Okay, volume of one brick. Okay, length times breadth times height. Multiply them together, make sure the units are corresponding. Everything is in terms of meters. Calculate it, we get meters, correct it to 2 significant. This is our answer, the volume of one brick. Next, determine the total weight. W equals to mg. So we will most likely be using this formula. Okay, total weight of 30 bricks. So what we calculated just now is actually the volume of one brick. So later we need to multiply by 30. Okay, so based on part 1, right, we have the volume. Volume wise, actually also in the question we have density. Density equals to mass over volume. You will be able to find out what's the mass of one brick. After that, multiply by 30, you will be able to get the mass of 30 bricks. And once you have mass, you can apply into this formula, W equals to mg. Then we can find the weight of 30 bricks. So let's see the answer. Okay, so based on this part here, we have density equals to mass over volume. So mass equals to density times volume. Okay, take the density that is in the question times the volume that you find previously. Remember to use the longer value, not the rounded value, to have a more accurate answer. Okay, after multiplying, this will be our answer. How do we know the unit of this mass, right? Actually, it depends on the density unit. Kg per meter cube. So it will be kg. This is the mass of one brick. Multiply by 30, we get the mass of 30 bricks. Subsequently, we'll apply the formula W equals to mg to find the weight of 30 bricks. So this will be the answer, correct to 2 significant. Okay, so let's move on to the next part. Okay, so the 30 bricks in part A are carried in a wheelbarrow, as shown in figure 5.1. The weight of the empty wheelbarrow is 110 newtons. Okay. The line of action of the combined weight of the wheelbarrow and the bricks acts at a perpendicular distance of 0.80 meters from the pivot. Okay, perpendicular distance. The vertical force is applied at the handle. Okay, so there's a force that is applied at the handle. 0.5 meter from the line of action of the combined weight as shown. Okay, calculate the force needed to hold the wheelbarrow and the bricks in a position. Okay, so to hold in the position, again, it means equilibrium. So like what we mentioned in the previous question, equilibrium means sum of anti-clockwise moment must be equal to the sum of clockwise moment. Okay, so let's take a look. Okay, we can actually analyze the diagram together first lah. Okay, there's a pivot here. Pivot, perpendicular distance, and the weight acting on it. Okay, so by moving this direction, right, this is actually clockwise moment. Clockwise moment. Okay, what's the force that is acting here, right here? Is actually the weight of 30 bricks together with the weight of the empty barrel. So don't miss that out. Okay, then the other part, right, here. There's a force acting on it. Okay, so for moments, the force and the distance must be perpendicular. Perpendicular, then go towards the pivot. So it's right here. So it's not just 0.5. You need to take 0.5 plus the distance here, which is 0.8. 0.8 together with 0.5. Okay, so let's see the working. By principle of moment, sum of anti-clockwise equals to sum of all anti-clockwise. Clockwise equal to anti-clockwise moments. Okay, so this part is actually the clockwise moment, force times distance, equals to the anti-clockwise moment, force times distance. So by simplifying, you'll be able to find force correct to 2 significant. Next question. A glass vase is to hold flowers as shown. Okay, explain how the stability of the vase is improved by having a wider base. Okay, so wider base, with a wider base, right, the vase will actually have a greater base area. The greater the base area, the more stable it will be. Okay, so here, the wider base means greater base area. Hence, more stable. Okay, next. A base made of thicker glass. Okay, so for the base here, if you notice, the glass is actually thicker. Okay, this by doing so, right, the center of gravity will be actually lowered. Because why? Actually, more mass. There's more mass at the base. So the thicker the base, the lower the center of gravity. Okay, the reason being is actually the mass at the bottom lah. Mass is at the bottom. Okay, so also, hence more stable. More stable. Okay, so this is a really quick question. Okay, let's move on to the next question. A child toy is shown in figure 7.1. Okay, a model plane B of weight 2.0 Newton, a model car C of weight 3.0 Newton are suspended at opposite ends of the rod PQ. The rod has negligible weight, so that means we can actually ignore the weight of the rod. Okay, the rod is suspended from the ceiling by a thread. The thread is tied to the rod at point T such that the distance TP is 24 cm. Okay, what do we need to calculate? Calculate the moment of the model plane B about point T. Okay, about point T, right, means this is actually the pivot. That's the pivot. Then moments means it's force times perpendicular distance. Okay, so based on the question, actually we have this force right here, 2.0 Newton. So the perpendicular distance will be right here. We'll actually stop from P to T because T is sort of like the pivot. Okay, so calculation wise, moment equals to force times perpendicular distance. 2.0 Newton times 24 cm. Okay, in this case we didn't convert it to meter, so the unit wise can be Newton cm. 48 Newton cm. Okay, next part. Calculate the distance TQ. Okay, distance TQ. Okay, where is the distance TQ? TQ is right here. So TQ is actually related to this moment of the car about the pivot T. So by doing this, right, the horizontal and the vertical, with the other side horizontal and vertical, this part is actually principle of moment already, because the sum of anti-clockwise moment must be equal to the sum of clockwise moment. Okay, so let's see. Total clockwise moment equals to total anti-clockwise moment. Make use of the answer that you found just previously. That is actually for the clockwise moment. Then the anti-clockwise moment, force times perpendicular distance. By dividing the 3.0 over to the other side, 48 divided by 3, we get TQ equals to 16. Okay, next. The tension on the thread. Okay, tension on the thread. Okay, tension is right here. So what we need to know, right, is that the upward force equals to the downward force. Okay. So all these are actually there's like forces acting on it. Okay. Yeah. So the total upward force equals to the total downward force. In this case, the downward force is actually the weight of the plane and also the weight of the car. 2.0 Newton and 3 Newton, sum them up together. This is 5.0 Newton. Alright, let's move on to the last question. A ram of weight 165 Newton and length 260 cm is fixed to a lorry as shown in figure 1.1. The NO of the ram is 240 cm horizontally away from the end of the lorry. The top T of the ram is 100 cm above the ground. Okay, so all these are on the diagram already. The weight of the ram acts at the midpoint of the ram. Okay, the weight of the ram is here, so it's also shown in the diagram. Okay, the lorry exerts a horizontal force Fh and a vertical force Fv on the ram at T, right here, as shown in figure 1.1. Calculate the clockwise moment at the end O of the ram. Okay, at the end O, so we are looking at this part. From here, we actually have the clockwise moment. The clockwise moment. Okay, so based on this part, there's a horizontal, okay, and a vertical. That's the force. Okay, so the force is 160 Newton. Perpendicular distance, because of moment formula, is right here. So we are using this 240 divided by 2, hence it's actually 1.2 meters. Okay, so clockwise moment is the weight of the ram and 1.2 meters because that's the midpoint of the ram. Multiply them together, we get 198 Newton meters. Write down an expression of the anti-clockwise moment at the NO of the ram. Okay, so the anti-clockwise moment is actually slightly more interesting because there are actually two forces that act on it. Okay, we can analyze one by one. Let's say the force that we are looking at is this force horizontal. For moments, it must be force times perpendicular distance. Okay, so if the force acting right here is actually a horizontal force, the distance perpendicular to it is actually 100 cm. Okay, but remember to convert it to meters lah. Okay, then we analyze the other one. The force vertical. For this force vertical, direction is facing upward. Okay, so by the formula of the moment force times perpendicular distance again, the distance must be perpendicular. Okay, perpendicular is 90 degree. Okay, from here, move towards the O. We are using this 2.4 meter. 240 cm. Can. 2.4 meter multiplied by the force vertical. Okay, so anti-clockwise moment, force vertical times the perpendicular distance, force horizontal times the perpendicular distance. Simplify it, you'll get this 2.4 Fv plus Fh. Next question. A man standing on the ram begins to climb up the ram. State how the clockwise moment about point O change. clockwise moment, if at all, as the man moves up the ramp. Okay, state how the clockwise moment. Okay, so there's a man walking upward. Okay, so what happens as the man walk upward? Or actually, what happens when the man is actually right at O? Okay, if the man stands right at O, there is actually no additional clockwise moment. Okay, why not? Because there's no perpendicular distance. So there's no additional moment acting on it. Okay, but once he actually starts moving, let's say he's here, the weight of him acts downward. Perpendicular distance is horizontal to the pivot. Horizontal, perpendicular. So as he move upward, right, the clockwise moment will increase. Okay, then as he go even more upward, the perpendicular distance increase even further. Hence, we can conclude that the clockwise moment increases as he walks up the ramp. Weight remains the same. Weight of the man remains the same as he walks up, but the perpendicular distance increase. That's why the clockwise moment also increase. So as the man stands at point O, there is no additional because there is no perpendicular distance. Okay, but as he move upward, perpendicular distance increase. Hence the sum of clockwise moment also increase. Force times distance. Force times perpendicular distance. Okay, next. State at which point another force must act on the ramp. Okay, so what's the other force that must act on the ramp? Is actually at point O. Point O. Okay. By considering moments about the top T of the ramp, explain why these other forces is necessary. Okay, so at the top, right, the top T of the ramp, there are actually two anti-clockwise moments that acts on it. Okay, so by principle of moments again, principle of moments. Okay, what's principle of moments again? Sum of anti-clockwise moment must be equal to the total sum of clockwise moment. Okay, so since there's actually the two anti-clockwise moment that acts on it, right? Here, two anti-clockwise moment that acts on it, then there must also be clockwise moment to actually balance up. Balance up the sum of the anti-clockwise. Okay, so let's take a look at what are the two anti-clockwise moments. Okay, considering moment about point T, there are two anti-clockwise moments. Okay, what are the two anti-clockwise moments? Is actually the first one is the moment exerted by the weight of the ramp. That's the first one. Okay, second one is the moment exerted by the weight of the man. Second one. Okay, so to balance it, to be in equilibrium, there must be clockwise moment to balance the sum of the anti-clockwise moment. Okay, so this clockwise moment exerted on the ground at the point O is actually necessary to balance it up. Yes. Okay, so that's the end of today's video. Hope everyone can learn something from it. Okay, bye bye.